All right, so this is our last lesson for chapter 6 on sinusoidal functions. It is 6.8. Looks like this. Okay, I'm going to go over this first example for real-world problems, and then I want you to practice the other ones. Okay. Most importantly, these are all basically starting with table of values, right? Like data charts. And we are going to take those tables and plot a graph. But what I'm going to show you, or I'm going to spend this lesson showing you, is how you can use Desmos to help you do that. Okay, how to actually use it to put in a table of values. Okay, so let's go over the first problem then. We have this table shows the average monthly high temperature for 1 year in this city. So I need to put in this data. So what I can do is go to the plus tab here. And if I click, I can do expression, node, table, folder. I'm going to do table. And here we have X1 and Y1. Okay, so check to make sure that you're plugging your x-axis values under X. So in this case, that would be the month. So I'm going to do 0, 1, 2, and so on. And then for the Y values, okay, when we have month 0, 0 will be January, is minus 18.6. And then we have minus 16.3, and so on, minus 9.1, and so on. Notice you can't see anything here. Why can't you see anything? Well, because these values are way off of our chart. Now you could just zoom out, right? And there they are. Right? You can click and drag and move it. Or you can go into settings and manually put in what you want, just like I showed you on a previous video. All right, so I'm just going to quickly pause and enter this information because I don't think you want to spend time watching me do that. And bam, there you go, all entered. Now, it doesn't quite look like it does on your sheets because it's very close together. So this does go from 0 to 60. It's a little bit too much since we're only going up to 11. So why don't I go from, I can go into the settings here and I can just manually change that. Maybe even starts at negative 12. We can start at negative 1 and go all the way up to 12. There you go. All right. Now what we're going to do is, well, question 2 says, what type of model best describes this graph? Linear, quadratic, or sinusoidal? Well, it's definitely not linear. If I were to draw a line of best fit, it's not going to be very good at all. It's not quadratic, right? It's hard to see a quadratic. It looks almost similar to a quadratic, but then this sort of loops back, and we know it's going to continue doing that because we know that these average temperatures throughout the year are fairly similar. They're repetitive. They're periodic, right? They don't just keep dropping forever. Okay, that would be terrible. All right, so we're going to say it's sinusoidal. Now we go on the back, we have other questions, so let's just go over them. Question 3 says, what's the domain of the function you have drawn for the given data? Okay, that's important, for the given data, what we have. What we have is between 0 and 11, so our domain is all values in X which are real, and it's going to be between, so greater than or equal to 0 and less than or equal to 11. Now technically you don't really have to say they're all real because they're not. It's 0, 1, 2, 3, 4, 5, right? In our data you can say they're all natural numbers, but since we know that this is a month, right, you would have maybe decimals. I mean, it's currently what, May, in the middle of May, okay, so 5.5. Okay, so we know that there's values existing in between those points is what I'm saying. So we're going to keep it as all real values. Number 4, what is the possible domain of this situation if the data continued for many years? So if it continues for many years, just over and over and over, that's infinite number of years, well then all we have to do is say X is greater than 0. Or if you want to cut it somewhere and maybe it continues for 100 years, well, I'll just do 100 times 12, because that's the number of months, so 1200. So stop at 1200. It's less than 1200. Okay, but we're not going to go into the negatives because nobody recorded data. All right, question 5 says, state the minimum and maximum values, include the proper units. Okay, so there's 2 ways to do that. You can look at your table and look for the minimum value. You can see right there it is minus 18.6, or you can actually just go on your graph and click on that lowest point, right? And it says minus 18.6. So our minimum value is minus 18.6, and our maximum value appears to be 17. Therefore, what's the range of this function? So then the range is in between those 2 values, right? It's all values in y, all real values in y, right? Where our range is greater than minus 18.6, greater than or equal to that, and it's less than or equal to 17. And so there's our range. Now it says write an equation for the axis of that curve. Remember, the axis of the curve is the center line. Right, up until now, it's been pretty easy to find that center line. For example, the line between 2 and 4, well, that's 3. In this case, what you would do is take your range, add them, and divide by 2. So you're going to take minus 18.6, add 17, and divide by 2. And that would be your equation of the axis. All right, so you plug that into your calculator and you'll get the equation of the axis to be y equals minus 0.8. So that didn't look, write that again. Minus 0.8. And it said proper units. Okay. Is that what it said? Right? Oh, no, that's not what it said. Oh, maximum minimum value, include proper units. Okay, so since it's temperature, you write degrees Celsius. All right, so there's our equation of the axis. And then it says, enter the data into the list of your graphing. Okay, we don't have a graphing calculator. We're using Desmos. And anytime this package asks you for a graphing calculator, we just use Desmos. That's what I've taught you to do it on. Perform a sinusoidal regression. A regression is, for example, a line of best fit, but we're not doing a line, we're doing a sinusoidal. So what we're going to do is the following. So we're going to go here, and we're going to add, okay, an expression. Okay. All right, so once we have a place to write our function is y, but since our data is y1, we're going to do y underscore 1. Okay, and we're not going to write equals. In order for the computer to generate a regression, we're going to do this swirly symbol. It's approximately equal to, and then we're going to have our equation, a times the sine, we don't really need the brackets, a times the sine of x minus c plus d. Oh, we don't want x, we want x1. There we go. Now, you can see it immediately generated something. Now, is that a good sinusoidal regression? No, it's terrible. And I'll tell you why it's terrible. It's because, well, what we've learned is our A is our vertical stretch or compression and our reflection about the x-axis. Our C is our phase shift and our D is our vertical shift. But when we're using sine functions to describe the real world, we are going to need a horizontal stretch. So I'm going to put a B right here in front of x1. There you go. Okay, you don't really need to understand B. We're not going to do any horizontal stretches, but in using Desmos, it does give you a really nice sinusoidal regression if you just throw that B in there. Okay, so we have that. Now, is it a good fit? Yes, we have a good fit. All right, so it says turn the scatter, question 10, turn the scatter plot off. We don't really need to do that. And use the graph to determine the average monthly temperature for the 38th month. Okay, So let's go all the way over here. The first month was 0, so the 38th month will be at 37, which is right here, 37. Okay, you can click on it and you can drag, and it looks like 37 is minus 7.4 degrees. All right, so that's the average monthly temperature of the 38th month. Next one says Jim Carrey wants to visit the city. His favorite temperature is 12 degrees. When should he plan on going? Use your graph to determine that. So 12 degrees. So where is it 12 degrees? Again, you can click and move it along this line. And we're looking for the y coordinate of 12. And it looks like it's in the middle of the 4th month. And since January is 0, I don't know why we've made January 0, but since January is 0, the 4th month is May. So in the middle of May, that would be the best time to visit. Okay, so definitely use Desmos to help you with the other practice problems on this sheet. But if you want, again, they do have the graph paper on the last page, and you can plot everything manually. That'll just take a little bit more time. Okay, once you're done, we are done this chapter. And so for the next couple of days, I'd like you to print out the Chapter 6 assignment and start working on those. And by the end of this week, I will post the Chapter 6 assignment Google form quiz for you to do, which again will be the exact same questions taken from the assignment. All right, have a good week.